Okay, so let's look at another example on osmotic pressure. In this one, we're told the solution is prepared by dissolving 0.035, of course, that dot shouldn't be there, kilogram of hemoglobin in enough water to make up a 1 liter in volume. So in other words, it's a 1 liter solution. The volume of the solution is 1 liter. The osmotic pressure of the solution is found to be 10 millimeter mercury at 25 degrees Celsius. Calculate the molar mass of hemoglobin. Now, the question is, how do we get to molar mass from the osmotic pressure? So if we start with the equation, so osmotic pressure is equal to CRT. What quantity can we relate to something of the molar mass? And I mean, the only quantity that's even remotely relatable to that is, of course, the number of moles. So the concentration is the number of moles over the volume multiplied by RT. And if we get the number of moles and we have the mass, we can, of course, get the molar mass. So, I mean, we calculate the number of moles. So the number of moles of hemoglobin is equal to the osmotic pressure multiplied by the volume divided by RT. So in this case, the osmotic pressure is 10.0 millimeter mercury multiplied by 1.00 liter. And we divide that by, so we need to get an R that has units of millimeter mercury and liter. And if we check our tables, we see 62.36359 liter millimeter mercury per Kelvin per mole. And the temperature at this is 25 degrees Celsius, so that's 298 Kelvin. Get 5.37 times 10 to the negative 4. Let's call it hemo. All right, so now it's mole hemo. Mole hemo. Okay, so that means the molar mass of hemoglobin, we're looking for mole per gram per mole. So that means we need to take the mass of hemoglobin divided by the number of mole of hemoglobin. Oh, I forgot my nice symbol. The molar mass of hemoglobin. So the mass is 0.0350 multiplied by 10 to the power 3 gram, because it's given in kilogram, divided by this 5.37 times 10 to the negative 4 mole. And that gives us a value of 65,103 significant figures, gram per mole. And that makes sense. Hemoglobin is a protein, I think, at least. Well, I think it's at least a very large organic molecule that captures iron in your blood or bonds of iron, and that's why your blood is red. So, and it's quite a large molecule, so it should have a large molar mass. Anyway, so yes, it's a protein. So it's another simple example of how you use the osmotic pressure of a solution to determine something useful. And it's typically used to determine the molar mass of substances. But yeah, not too difficult. Okay, I hope I see you in the next video.